Hi, this is an interview for Edularity. Today we are with Walter Venders. How is creating or programming related to problem solving and to mathematics especially?
Okay, so Cynthia Solomon, who was one of the co-inventors of the programming language Logo, which was the first programming language for children, made the observation in the late 1960s, so 50 years ago. She made the observation that debugging, so fixing the bugs, the problems in your program is actually the real learning opportunity. And it sort of actually relates back to what I was saying earlier about reflection as well. When you stop and look at what went wrong and how can I make it better, that's a real learning opportunity. And so one of the nicest things about programming is that programming is very forgiving. In other words, there's nothing to break. Or if you do break something, it's easy to fix. There's no harm to be done. I used to make the analogy to learning to drive a car. When I was young, cars were made of steel. They were heavy. And inevitably, when I drove off the road and hit that tree, all the energy of the impact went into the tree and into the driver. In the automotive industry, it took them about 50, 60 years to figure out that people are more important than cars. So they invented this concept of the crumple zone. The crumple zone is crushes in the front, that bumper made of plastic, absorbs all the energy so that the tree and the driver and passenger are safe. And you can think about programming as being an intellectual crumple zone. It's a place where you can take intellectual risks, try things, break things, and nothing bad happens. So to me, it's a really nice vehicle for that kind of exploration. Now, I think there's a little bit more to it as well. And there's a lot of talk these days about computational thinking.
Right.
Computational thinking is one of these phrases that gets stuffed with anything that somebody wants to talk about. Everybody has their own definition for the convenience of whatever argument they're making. But I will argue that computational thinking has a lot to do with algorithmic thinking. It has a lot to do with how do we actually solve problems and how do the various inventions such as sorting, there are all these different mechanisms we use in computer science that are sort of the dread of programming students because, I've got to write a bubble sort, I've got to do this, I've got to do that. The point isn't that you can code this algorithm or code that algorithm. The point is that you learn about what an algorithm is. An algorithm is an affordance for helping you solve problems. And learning how to use these affordances to be a problem solver, that's the power. And so programming and digital technology is a collection of tools, and it's really about how do you experience these tools, how do you use these tools to solve problems in a safe environment, in a place where you can take risks, make mistakes, and learn something.
So would you say this idea is one of the main pillars of constructionism?
Well, I don't know that digital technology per se needs to be a main pillar, but I think it's a very convenient tool. It's just sort of the go-to tool because it's so useful.
Yeah, because I also say that constructionism, the debugging can be done through art or through some other ways.
Absolutely. In fact, one of my favorite projects from one of Seymour's students years ago, it was a project called About Knots. The technology was 18 inches of string or rope, and you tied knots. But then when you tied the knots, you engaged in this internal dialogue and a dialogue with your peers about what's this knot for? How is this knot different than that knot? What can I do with this knot that I can't do with that knot? How do I teach this knot to you? There's all these different things that you can engage in around constructing knowledge and around sharing knowledge, even with something as simple as knot tying. I think that there's lots of opportunities outside of the realm of digital technology where constructionism can apply. And again, probably, as you mentioned, the richest of these is in the arts, and the most available of these is in the arts. And there's also typically a cultural affinity to the arts. It's a great place to start. But again, the power of digital technologies that amplifies all that experience. So, for example, one of the things we do with the Sugar software is we let the children build a portfolio with the Sugar software. So the Sugar software is automatically accumulating a journal of everything they've done, and then it becomes a portfolio, it becomes a history of their work. And the nice thing about having that history is, A, you can refer to it and look at your own personal progress, and B, you can say, hey, look, I can do this. And it's not just, I learned about this in school. No, I can do this. See, it's right there in my portfolio. So when it comes time to get a job, for example, look what I can do. You better hire me because I'm good. I think that there are a lot of ways in which digital technology enhances these kinds of activities, but it's not exclusive to digital technology at all.
So we go back to reflection. And we also get the notion of this phrase from Papert: you cannot think about thinking when you're not
Yeah,
present.
yeah, yeah. You can't think about thinking without thinking about
About
thinking about
thinking.
something.
Yes.
Okay, so, and the something, again, doesn't really matter. The something should be whatever the child is passionate about.
Yes.
But as long as they're thinking about something they're passionate about, that's where the learning happens.
Can you explain the phrase for those who really need to understand it?
Well, it's a tongue twister. It's absolutely a tongue twister. In some sense, it really just means that you can't think about things in isolation, in a vacuum. You have to think about things in terms of something that's tangible, something that's real, something that's happening, something you're doing.
Yeah, so for example, the knots, they were helping you to understand how the knots were working, to understand a bigger picture of what you were creating.
Right.
Are you listening? Damn.